How we can apply a triangular UDL or uniform distributed load on a beam, and how we can apply a roller support or translational support to a beam, and what is the difference between fixed support and the roller supports. So in this lectures you will learn this all by using the simulation study of this beam. So let's start our problem now. So first of all, open SolidWorks and change units to meter, kilogram, seconds, and make a simple sketch on the front planes. Then draw a line of length 12 meter. Assign the dimensions 12 meter. Okay. Now exit from sketch and go to the measurements. Then select the structural members. From here, select the ISO. Then from the type, select the SB beams and size is 120 by 12. And click on the groups. Then select this line. So if we zoom, you can see we have assigned a beam profile to this structure members. We can rotate this profile to 90 degree so that this surface may come upward. So go to drop down and change the angle of 90 degree to locate these profiles. You can see the results is here. Okay, so we have made a beam with a definite profiles. Now start your simulations and click a new study. You can give a specific name to this study and click OK. After that, expand your cut list. You can see the beam. Go to edit definitions. You can see beam type has been already selected. Now assign the material, that is alloy steel. Go to the apply edit material, then apply alloy steel to this beam, then close. After that, bring your front view. This beam has two ends, this one and this one, and the both ends are free. Now go to the fixtures. We will apply a fixed boundary condition here, and but for this joint or this end, we will apply a roller support in y directions, because this joint only can move in the x directions. So go to the fixtures and select the fixed geometry. From here, select the fixed geometry from the type and select this one. Okay. After that, again go to the fixture, fixed geometry. Then go to the use the reference geometry, select this joint, and from the directions, select the front plane. Now apply a support in the y directions. You can change the size of the support symbols to 200. Okay. So we have applied a fixed support here. You can change the symbols size for fixed support also. Go to the symbol size and change it to 200. So we apply a fixed support at this end and a support only in the y direction in this. That this end can roll in the x direction but cannot move in the y directions. After that, the main point is to apply a triangular uniform distributed load. Go to the force and select the beam and select this beam. From direction, select the front planes. Now click on the non-uniform distributed loads. You can see from here is a triangular distribution, and this is the parabolic distribution, and this is the elliptical distribution. So select the triangular distributions, then click from the force, click on the y directions and change the reverse the directions. Now apply the force of 4000 Newton. Also change the symbol settings to 200. So we have applied a triangular non-uniform distributed load here on this beam. And now it's time to run your simulation study and wait until your solution converges. So our solution has been completed now. Here you can see the beam force as well as stress and the shear force diagrams. Go to edit definitions from the results and select the units to megapascals. You can see the maximum stress is 131 megapascal. That is less than that of the yield strength of the material. Here you can see the deformation behavior of both. If we click on the deformation, here the maximum deformation occur here, that is 68.95 millimeter. If we check the deformation behavior, go and animate it. So feel the difference at the of deformation at this joint and at this joint, because this is the fixed end support and this is the roller support. After that, you can also draw the beam diagrams. Go to the define beam diagrams and select the shear force in direction once. Okay. So here you can see the shear force is positive at this end, that is 1.3 Newton. And here the shear force is negative, that is 2625 Newton here. Similarly, we can apply or draw the bending moment diagrams. Go to the beam diagram, then select the moment about direction 1. Okay. So here is the bending moment in direction 1. Similarly, we can calculate the moment in directions 2. Now switch to the top view. So this is the actual moment that will occur. That is the here is the positive, that is 7.5 kilonewton meter, and there is the and here is only minus 4.5 Newton meter. Minus 4.5 maximum will occur here, but there is no moments at this free end because this roller support is free to roll, so no moment develop at this support. But we know that this fixed support has resistance to move or rotate, so movement has been developed at this fixed support. So this is the difference between the fixed support and a roller support or slider or translational support in one directions. So I hope you enjoyed this simulation tutorials. Please subscribe my channel and give your comments. Thank you for watching.